In the previous episode of Digital Electronics, three basic gates, that is, AND, OR, and NOT were discussed. Using these, other functions can be derived. These logic gates are called derived gates. They are of four types. Let us study them one by one. This is a two-input AND gate. The output is A and B. It is followed by a NOT gate to give the output Y, which is not AB, that is AB bar. The derived gate is called a NAND gate. The symbol is a bubble after the AND gate. The logical expression of NAND gate is AB bar. If we see the truth table, the output of NAND gate is simply the complement of AND gate. Consider a chemical factory where the exhaust fans help to blow the pollutants out. When the fans are operating, a logic 1 is obtained. The output of all the fans is connected to a NAND gate, which is followed by the alarm circuit. When all the fans are operating, the NAND gate output is low, disconnecting it from the alarm. When any one fails, the circuit is connected to the alarm and the buzzer goes off. OR gate followed by a NOT gate is a NOT OR a NOR gate. The output Y is complement of OR gate output. Let us look at its truth table. When both the inputs are at logic 0, the output of OR gate is 0 and NOR gate is 1. For all the other input combinations, the output of NOR gate is 0. For example, a washing machine has three sensors. One sensor checks if the lid is open. If the lid is closed, the sensor generates a logic 0. Another sensor checks the weight limit. If the machine is overloaded, it generates an output 1, otherwise 0. The last sensor produces a high output if the water level is minimum. Since the water level is optimum, it gives a logic 0. These outputs go to a NOR gate which is connected to the main circuit. During normal operation of washing machine, all sensors produce a low output. Output of NOR gate is 1 and the path is connected to main switch. However, during erogenous conditions, a low NOR gate output disconnects the washing machine from the main switch. The next derived gate is an XOR or an exclusive OR gate. It can be explained using a two-sided switch. In a room, the light switch is present near the door, so if you enter the room and it's dark, one could turn on the lights by switching the door side switch. There is another bedside switch for the same tube light for easy accessibility. If however you fall asleep on bed, you could use the light switch near the bedside to turn it off. Both the switches are connected to an XOR gate. In the event when one is on or at logic 1, the output is high as seen in the Boolean expression, that is A bar B or AB bar. Suppose A is 0, A bar will be 1. If B is 1, B bar is 0. If we put the values in the Boolean expression, the output of Y is 1. Whereas the exclusive NOR gate, XNOR, requires both the input at the same logic to generate a high output. It is complement of XOR gate. It can be seen from the logical expression.
Thanks for watching. Please like and share it with your friends and subscribe to our channel for such more interesting videos. Click on the bell icon after subscribing and never miss an update from Practical Ninjas. Do share your comments in the section below. Visit our website and follow us for more informative content using the links in the description.